Hi, welcome. This is my project, Venus Unveiled: Hot Planet Cool Science by David Mondragon. This is the Lunar and Planetary Science Conference project, and I'll be sharing some basic facts or basic information. Venus is the second planet from the Sun and the hottest planet in our solar system. The average surface temperature on Venus is about 867 Fahrenheit or 464 Celsius. This is due to the massive greenhouse effect caused by its thick carbon dioxide-rich atmosphere. Venus is estimated to have about 85,000 volcanoes. This is my first abstract, Channelized Lava Flow on Venus, New Insight into Distribution, Morphology, Rheology, and Emplacement Process. And these right here are the authors of this. Venus's lava flow is similar to ballistic lava flow on Earth. So it has a lot of lava with a lot of eruption on it. And the two models we use to utilize the lava flow is the rheolite method. It talks about how we use the adapted version by PyFlow, which we use to model the thermodynamics of lava and the solidification of Venus's lava flow. Venus's lava flow is cooler and slower than the lavas from the other terrestrial planets like Earth, with a higher effusion rate that helps reproduce the lava in longer areas. As you see on this map, it shows a short distance of this level of lava flow compared to others you see on these little red dots. And this is my second abstract, the present-day interior of Venus as predicted by global geodynamical models and constructed by observation. Venus today is one of the most extreme places in our solar system, having an atmosphere of CO2 and dominated by volcanic features. Like we talked about, Venus has a greenhouse effect where it traps in all that carbon dioxide. To compute the full thermal evolution of Venus, we use GAIA. With this, we're able to solve numerical equations for the mass, linear, and momentum of the thermal energy and the temporal distribution of the temperature field in the interior of the planetary body. So with this, we're able to measure how hot it'd be inside the interior, what's the most hot level of the crust, what's the least hottest level on the crust, and we also use 3D models to calculate the tidal deformation and show models with the core radius that Venus has is larger than 400 kilometers. This is my third and final abstract, Field in vitro sulfuric acid vapor abundance and effects on radial propagation on Venus, with this author right here. Venus's atmosphere is so hot and thick that it's laden with radiatively active molecules that has an effect on the propagation of electromagnetic radiation in the atmosphere, being an absorber of microradiation. The clouds on Venus with high altitudes of 35 to 55 kilometers is dominated by sulfuric acid vapor, but the altitude below has a vapor condensed into droplets above hotter depths, at which the vapor becomes disassociated into water and sulfuric trioxide. Venus acid profile has been measured by this program called Da Vinci. It shows the maximum abundance of sulfuric acid and H2SO4. In this graph, we see the high points, the high maximum points, the low maximum points, and the medium maximum points. With this, we measure the sulfuric levels or the abundance of it that is seen on the atmosphere of Venus, and we are able to say the concentration levels that develop all over time. With the high altitude that Venus has, we can see that as soon as it drops from the sulfuric acid, it goes into vapor droplets. From there, it become lower and becomes more of a vapor gas. I just want to say thank you for listening to my slideshow presentation.